Hi, my name is Tony. I'm a Senior Program Manager with Microsoft, and I'm here today to present to you a shortened version of a West presentation titled Designing a Secure Boot Experience with Modern Firmware. This presentation is particularly technical in nature. There are two parts to the presentation. We jump right into the secure boot policies as Microsoft views them as defined in the UEFI specification. That is in the specification 2.3.1. We also have a presentation by Inside Software, who was gracious enough to give us a view into their implementation and designs of secure boot as well. Inside, along with many of our other partners, are doing an outstanding job in the industry of enabling security in the boot path with UEFI, and Microsoft is proud to be working with Inside as well as all of our other partners. The secure boot policies that Windows relies on is again defined in Chapter 27 of the UEFI specification. The new revisions to that specification that we most care about is the inclusion of time-based authenticated variables. Windows 8 does not support monotonic count variables. And so with that in mind, that is the reason why we are asking through our certification program that Windows 8 logo systems be UEFI 2.3.1 capable. These policies are basically a mechanism to establish a root of trust, and that root of trust in firmware works in conjunction with the OS to essentially enable and maintain secure boot. The insertion of platform keys in firmware is what creates basically the platforms that you see and use today that you buy in stores. And essentially without that platform key, the system is not in a secure state and there is no authentication. And typically systems without platform keys will be systems that are found in manufacturing processes as well as perhaps in test environments at particular OEM and ODM locations. In discussion of the keys are defined in section 27.5, and there are several types of keys that are defined as part of the secure boot policies. There is the platform key, and that platform key is essentially a key that establishes the trust relationship between the platform owner and the platform firmware. The platform owner in this case is either the IBV, the company that creates the BIOS, the ODM, or the OEM. The platform owner in this case is not the consumer or the customer of that PC. The platform key is not a new concept. It's been around for many years. It's been part of BIOS, and we just continue to leverage that through UEFI, meaning I should say the UEFI specification continues to leverage that. And we utilize that as basically the root key to establish trust into the system. There is also a second set of keys called the key exchange key. And the key exchange key, as defined in the UEFI spec, is what establishes a trust relationship between the platform firmware and the operating system. As you'll see shortly, there will be a diagram that describes the relationship of these keys. The keys themselves aren't particularly chained to each other. However, they exist in separate but dependent databases in firmware. And modifications to the KEK database can only be done by the owner of the platform. And the KEK keys can then modify the underlying databases that contain signatures for approved OS loaders or UEFI software and drivers. The firmware may also allow for self-provisioning of a user with physical presence, and Microsoft definitely advocates this policy for systems to allow consumers to maintain and manage the set of keys on their system. And most of our partners are already working in this direction, and we are very happy to be working with them to support this direction as well. The hierarchy of variables in firmware is defined in section 27.6 and 7.2. In this hierarchy, the OEM owns the platform key, and that's usually the case. Microsoft will provide a key exchange key, and will also provide a UEFI certificate authority as well as the Windows 8 signature, which is what the Windows 8 operating system will be signed with. In total, we expect at least 4 signatures to be in firmware, and there may be more. An OEM may implement the capability to perhaps execute other software or other OS loaders, and that's certainly up to the OEM and the BIOS manufacturers to dictate the policies of which signatures go into firmware. From Microsoft's point of view, we require at least 4. Microsoft is also offering support for UEFI option ROM driver writers to sign their UEFI option ROMs through the Windows signing authority, through Windows WinQual. And we're very proud to announce that as well. How does this apply to Windows 8? Well, for Windows 8 today, we already have a Secure Boot pre-release tests that are available through the Connect site for those who are members of the Connect program for Windows 8. We also have the latest Windows certification document, which was published in early November. You can review that for more implementation guidelines and suggestions for how to enable Secure Boot on your system and what we validate. Again, Microsoft is providing the KEK. We are providing the UEFI signing authority key that we are hosting, and we are also providing Windows 8 signatures. And of course, the platform manufacturer owns the PK, so that will be predetermined and pre-allocated by the OEM, and the policies are owned by the OEM or ODM. And finally, the Microsoft KEK is what will allow Windows 8 to provide updates to the signature databases. So in this respect, the presence of a KEK key, the Microsoft KEK key, is what will allow us to manage revocation of any malware that is found in the future. In terms of the databases, we spoke a lot about the keys, but in terms of the databases, there is the KEK database, which grants access to the signatures that we described earlier. In terms of in relation to UEFI terminology, if you refer to section 27.8.1, we have a DB and a DBX database. The so-called DB database is the database of allowed signatures. That is the database that allows option ROMs, that allows OS loaders to execute per the Secure Boot policy on a specific platform. This is an area that is independent of Microsoft implementation. This is specifically owned by the OEM, ODM, and of course the BIOS manufacturer. The presence of the Microsoft UEFI signature as well as the Windows 8 signature is what will allow the Windows 8 bootloader to execute in a secure firmware environment, as well as properly created and signed UEFI option ROM drivers as well. The DBX database, or also known as the revocation database, is the database that will contain signatures of images of UEFI firmware that should not be allowed to execute. This is the database that will protect the consumer from malware. This is the database that Microsoft will manage as part of our OS, and this is also a database that other enterprises can use to prohibit execution of other firmware images as well. Now overall, our recommendation is that the minimum database size be 64 kilobytes. Certainly it can be larger, but we understand that ROM space is a valuable commodity, and we think 64 kilobytes should be sufficient for everyday operation. And then finally, the platform key. The platform key is what identifies a system as being owned by a particular platform owner. Now, the public key is what's inserted into firmware, the public portion of the platform key. And the private portion of the platform key is what is used to sign things like firmware updates and also other types of updates that may be required, perhaps modifications and so forth and so on. And as a reminder, there's no implied chaining here between the DB signatures, the KEK signatures, and the platform key signatures. Now, when discussing the reset scenario, it's very important that factory resets only be BIOS initiated. As you may have read from the Windows 8 Microsoft build blog, we do not advocate the programmatic changing of Secure Boot. We do not advocate the programmatic management of Secure Boot policies from the OS or any application after an OS loads. And because of that, we must also take care to not reset the BIOS except perhaps through BIOS itself or through a physically present user. And so when resetting firmware, it's important to reset the firmware to initial states of the DB, and those initial states will be saved into ROM at the time that the PC is built. Finally, we'll discuss provisioning keys. And in provisioning keys, Microsoft sees as there being three generic options that are available to OEMs and system builders and so forth and so on. The first option is the use of a UEFI shell to provision the keys, using tools such as setVariable.efi. And in this process, you can add DB and DBX tools with the Microsoft signature. You can add the KEK into the platform. And then finally, you can add the PK. And if you refer to the UEFI specification, it is the addition of the PK into a bare metal system that would essentially enable secure boot. So this is one particular option that some OEMs and ODMs may choose to utilize in their processes. The second one is you can actually use Windows PowerShell, and we'll be documenting that as well about how to use it, and you can see more details in this slide deck. And using Windows PowerShell, you can actually use a commandlet, a PowerShell commandlet, to actually introduce keys into the firmware. Now, this one's particularly useful for OEMs that choose to install Windows 8 on a platform that's still in setup mode and wishes to perform configuration of that platform from Windows itself. Finally, the third option is you basically bake it into your ROM image. And this perhaps is the most popular option. It's the most straightforward and perhaps requires the least amount of changes in the manufacturing floor. And on this one, you basically create a flash map of the image you wish to burn, and that flash map essentially contains the default settings for those databases. Now, the second part of the presentation was given by Jeff Bobson, who is Vice President of Engineering at Inside Software. Jeff was gracious enough to discuss Inside Software's views on security and discussion of their design elements. And his presentation was really good at taking a step back to discuss from a player in the industry as to why legacy BIOS was weak. Discussion also centered around the different sets of tools and processes that are available to OEMs, and in particular pay attention to Inside's positioning on how they can allow users to provision tools and hashes themselves of images in firmware. So this was an exciting portion of the presentation, and I encourage you to browse through that material at your own leisure. In closing, UEFI is an important strategic objective of Windows 8. There are lots of features that depend on UEFI. We feel that using UEFI is going to bring benefit both in terms of security, performance, look and feel. In this particular session, we discussed the security aspects of UEFI. And for the different market segments, as we continue to discuss these slides from Wes, it's important that you recognize what is your role in this scenario. If you're an IHV, it is to develop option ROM supports with UEFI. It's to update your manufacturing tool support and device drivers with UEFI support. If you're an ODM, it's all about updating your factory tools and your processes to utilize UEFI, perhaps using Windows PE and other tools. If you're an OEM, it's about thinking about how to secure your firmware and how to optimize that firmware for speed. And finally, the consumer. The consumers will see a much more friendly, faster performant experience with PCs and Windows 8, and we really look forward to enabling these new PCs for everyday use. And finally, to recap some of the recommendations for Secure Boot, there are various resources that will aid you in your design of Secure Boot. The first one is the UEFI specification itself. Again, the Windows 8 certification requirements. We have some tests as part of those requirements. UEFI itself has a self-certification test. We encourage you to look at that as well. And then also you can always contact the UEFI Specification Working Group, the USWG, and more information on that can be found on uefi.org. And finally, again, the 64K flash allowance that we made, for those of you who are wondering, will actually allow around roughly 1,875 updates to the DBX database. So that's essentially almost 1,800 plus malware hashes that can be stored in the DBX. Finally, I'd like to also make more of a detailed announcement regarding our UEFI signing portal. We plan to allow UEFI driver developers to sign their UEFI option ROMs through WinQual. The service will be available to all the WinQual members. There's over 11,000 companies worldwide who are part of WinQual. Although there is an administrative cost to enroll as a member if you're not a member yet, the good news is that signing UEFI option ROM, UEFI binaries will be free of charge, and the code will be signed by the Microsoft UEFI Certificate Authority. So if you're a UEFI option ROM developer and if you use the WinQual portal for signing in the Windows 8 timeframe, your code will be signed against the UEFI certificate, and any OEM having that UEFI Microsoft certificate in their database will automatically allow your code to execute. And in discussion of milestones, it's really important that we understand with Windows 8 approaching launch sometime in the future, it's important to understand that there are certain milestones that you should consider. If you are new to this right now, then the important thing is to read and understand the documentation that's available. You should plan about a month from now to start to execute your secure boot tests. In 2 months, you should really think about finalizing your manufacturing processes to address secure boot and align those with your IHVs and your option ROM schedules. And then finally, 90 days from now and more, consider freezing your firmware. Consider self-testing it. Consider getting a beta program. Get some runway with it and test it. And finally, the next milestone to prepare for, as we all know, is the beta milestone. And so now is the time to really finalize the firmware on your systems and to finalize the designs of your secure boot firmware. Again, my name is Tony Mangiafesti. Thank you for your time. And if you'd like more information, please visit this presentation on the WES website. Thank you.